started recording. We did these in chapter 3. Today we're going to focus mostly on negative exponents, but we're going to use all of these other properties, and so that's why I want to review it. Product of powers, that is when I have the same base and they're being multiplied together. What do I do with the 2 and the 3? Add them. Okay, so my key word here is add. Okay, so this is x to the 2 plus 3, which is x to the 5th. Okay, so my final answer there is x to the 5th. Quotient of powers is when I am dividing and they have the same base. What do I do here? Subtract. So it's going to be x to the 5 minus 2, and that's x to the 3rd. So my key word here is subtract. Subtract. Now, power of products and power to a power are very often used at the same time. Very often they're used together. Okay? Very, very often they're used together. Power of products means if I have x times y and I raise that to the second power, what do I have to do with that 2?
Put it in front of each one.
I don't put it in front of each one, but it's the exponent for each one.
Exponent.
Good. So I'm going to give that 2 to the x. So I've got x squared, and then I'm going to give the 2 to the y. So I've got y squared. Okay, so that 2 belongs to both. It's not the distributive property, but sometimes students think of it as the distributive property. Okay? Now, a power of a power is when I have a power raised to another power. Okay? Here, I multiply. That's what I'm doing with this one, is I multiply. So I have x to the 2 times 3. That gives me x to the 6th. Okay? Now, this power of products and power of a power, they happen at the same time quite a bit. Okay, so I have x squared, y to the 3rd, and all of that's being raised to the 4th. Okay, so I'm doing 2 things here. I'm giving both of those that raised to the 4th, and I've got x squared to the 4th power, so I multiply. So this, I would end up with x to the 8th and y to the 12th. And we can do that because we're using both of these powers at the same, or both of those properties at the same time. Okay, and that's usually how you see it. Okay, a negative exponent. If I've got x to the negative 3rd, where does it go? Where does that go? Yes, it goes to the denominator, okay? Negative exponents are reciprocals of each other. They are reciprocals. So x to the negative 3rd becomes 1 over x to the 3rd. 1 over x to the 3rd. What if I have a negative exponent in the denominator? Bless you. What if I have y to the negative 2 in the denominator? It goes to the numerator. Excellent. So then I have y squared. Okay? So those are negative exponents. Okay. If I have something raised to the 0 power, what do I get? 1. X to the 0 power is 1. X to the 0 power is 1. I can have 10 to the 0 power, and I could have negative 30 to the 0 power. And I'm always going to get 1. Now, in this situation, if I have negative 2 raised to the 0 power, and then I have negative 2 in parentheses raised to the 0 power, okay? The negative 2 in parentheses, so that's the bottom one. The negative 2 in parentheses, I am going to get 1. The negative 2 in parentheses, I'm going to get 1. Because right here, the negative is being raised to the 0 power and the 2 is being raised to the 0 power. Okay? The negative and the 2. Here, the only thing that's being raised to the 0 power is the 2. So the negative is separate. You've got to think about this as a negative, and you've got to think about this as a 2. The negative is not being raised to the 0 power, so I keep it. And so the answer to this would be negative 1. Can you shut the door for me, Mark? So it's super important that you see the difference between those two. Okay? Here, the only thing that's being raised to the 0 power is the 2, not the negative. Here, the negative and the 2 is being raised to the 0 power. Okay? It's one of those questions that sometimes comes back to us, and we have to think about it a little more. Okay? Are we ready to use these properties? Okay. Here I have x squared, and I am multiplying that times x to the negative 5th. For most of these, I am going to have 2 different ways that I can solve this. I'm going to have 2 different ways that I can solve this. Okay? So my first option is I am going to say x to the 2 plus negative 5. Okay? I used my product of powers property. I added the exponents. I get 2 plus negative 5. What is 2 plus negative 5?
Negative 3.
Good.
Minus negative 3.
So I have x to the negative 3. That's a negative exponent, so I've got to move it to the denominator. So x to the negative 3 becomes 1 over x to the 3rd. Okay? That is one way that you can solve it. Now I want you to look at another way. And both ways get us to the same answer. Okay? I'm going to deal with that x to the negative 5th first. Okay? I'm going to deal with the x to the negative 5th first. Okay? So I am going to move that x to the negative 5th to the denominator. So I'm going to say x squared over x to the 5th. Okay? What that means is x times x over x times x times x times x times x. If it's in the numerator and it's in the denominator, I can cancel it. And here I'm left with 1 over x to the 3rd. I get the same answer no matter which way I deal with it. Okay? No matter which way I deal with it, I get the same answer. Yes, sir?
So do we do either one?
Either way. Either way.
I'm sorry.
It's okay. Okay, you do it either way. Okay, can I go to the next screen? Okay. Here I have x to the negative 2 raised to the 4th power. This is a power to a power property. So I can do x to the negative 2 times 4. Because when I go from a power to a power, I multiply. Power to a power, I multiply. So this becomes x to the negative 8. X to the negative 8. Where does that x to the negative 8 go? Denominator. So it's 1 over x to the 8th power. Okay, now that's just one option. Okay, you can do it different ways. What I'm going to do here is I'm going to deal with that x to the negative 2. I'm going to deal with that negative 2 first. Okay, so inside parentheses, what I'm going to have is 1 over x squared. So I dealt with the negative exponent first. Okay, and you certainly can do it that way. Okay, now I'm going to give that 4 to all parts. Okay, so I'm going to have 1 to the 4th. Then I'm going to have x squared times 4. 1 times 1 times 1 times 1. It's still 1. And then what do I have in the denominator? Okay? So either way is fine. Either way is completely fine. Okay? We ready to keep going? Okay. Now I have something in parentheses that I'm raising to a negative power. Okay, so I have x squared, y to the negative 3rd, and all of that is being raised to the negative 4th power. So what I'm going to do first is I'm going to give that negative 4 to everything. Okay? So I'm going to have x to the 2 times negative 4. And then I'm going to have y to the negative 3 times negative 4. Okay? So then I'm left with x to the negative 8 and y to the positive 12. What stays in the numerator? The positive, the y to the 12, good. And what goes to the denominator? What goes to the denominator? X to, yeah. So then I have x to the 8th in the denominator. Okay? Now, again, we can do this 2 different ways. So what I'm going to do now is I'm going to deal with what's inside parentheses first. So I have x squared, y to the negative 3rd. All of that's raised to the negative 4th. So I'm going to deal with this y to the negative 3rd first. So inside parentheses, I'm going to have x squared over y to the negative 3rd. Nope, it's not going to be negative, right? It's going to be positive because I moved it to the denominator. Okay? Now I'm going to deal with that, everything being raised to the negative 4th. So I have x to the 2 times negative 4, y to the 3 times negative 4. So now I have x to the negative 8 and y to the negative 12. So now what do I have to do? Switch them. Okay, so I'm going to have to switch back. So I have y to the 12th in the numerator, x to the 8th in the denominator. In this particular situation, the method on the left is quicker. Okay, the method on the left is quicker. You know, sometimes it just depends. You know, we're going to do one at the very end. The method where we deal with the stuff inside first is faster. Okay? So you just need to be aware that there's 2 different ways that you can solve these. Okay? Okay. Can I go to the next screen? Okay. A to the 3rd over b to the negative 5th. A to the 3rd over b to the negative 5th. And all of that is raised to the negative 2. So the first thing that I'm going to do is I'm going to give that negative 2 to everybody. So I'm going to have a to the 3 times negative 2. Then I'm going to have b to the negative 5 times the negative 2. So I'm left with a to the negative 6 over b to the positive 10. So my a has got to go to the denominator. When I move my a to the denominator, what am I left with in the numerator? 1. Good. Excellent job. You are left with 1. Excellent. Excellent. Now, as always, there is a second method. Second method. I have a to the 3rd over b to the negative 5th. All of that's raised to the negative 2nd. I'm going to simplify what's inside the parentheses first. I'm going to simplify what's inside the parentheses first. So I have a to the 3rd times b to the 5th. I moved that b to the negative 5th to the numerator. Then I'm multiplying all of this times negative 2. So I have a to the 3 times negative 2, b to the 5 times negative 2. So now I've got to move both of them to the denominator because they have negative exponents. We doing okay? Okay. Can I go to the next one? Okay. Here I have x to the negative 4th over x squared. X to the negative 4th over x to the negative 2nd. I'm sorry, I said just squared. X to the negative 4th over x to the negative 2. Okay? My first method that I could do is I could subtract because I'm dividing. So I could say x to the negative 4th minus negative 2. I'm sorry? Yes. Good. Because the minus and minus becomes plus or positive. So I am left with x to the negative 2. And that becomes 1 over x squared. Okay? My option 2 is I have x to the negative 4th over x to the negative 2. I'm going to rewrite those as positive exponents. So I have x squared in the numerator and I have x to the 4th in the denominator. Okay? What's the difference between 4 and 2? 2. Do I have more on the top or more on the bottom?
The bottom.
So I'm going to have 1 over x squared. I can also write this as x times x over x times x times x times x. Okay? So there's multiple ways that we can do that one. Okay? Can I go to the next screen? We got it? Okay. Now, the question that you ask yourself here, are there any exponents outside the parentheses? Okay? Are there any exponents outside the parentheses? What I'm talking about is something like this. Do you see how everything in there is raised to the negative 2? That's what I'm asking. Do I have anything here or here that the entire monomial is being raised to? And I don't. I do not. Okay? So what I'm going to do here is the first thing that I'm going to do is I'm going to address my numbers. My numbers are 3 and 4. The second thing I'm going to do is I'm going to address my x's. And the third thing that I'm going to do is address my y's. You can think about them separately. Okay? So I have 3 times 4. Those are numbers. They follow our properties of real numbers. 3 times 4. What is 3 times 4? 12. Okay? Then I'm going to deal with my x squared and my x to the negative 3. Those are being multiplied together, so I add their exponents.
X
So,
to the negative first.
yes, it will be x to the negative 1. Okay, then I look at my y's. What exponent is with that y?
Negative 4.
Nope, my second y.
Oh.
1. Okay? So then I have y to the negative 4 plus positive 1. So I have 12 x to the negative 1, y to the negative 3. My 12 stays in my numerator. My x and my y go to the denominator. And you could simplify things inside the parentheses first. I don't really think your second option for this one is a great option, so I would not really encourage you to do that on this one or the next one. Okay? Can I go to the next screen? Okay. So for this one, we are going to deal with our numbers first. So we're going to divide. Then I'm going to deal with my A's. Then I'm going to deal with my B's. My numbers, my A's, and my B's. Okay? So 12 divided by negative 3. What is 12 divided by negative 3?
Negative 4.
Negative 4. Now I'm going to pause right there for just a second. This is a real number. This is not an exponent. Okay? Because that 4 is negative, that does not mean you move it to the denominator. That's just a negative 4. It is not an exponent. So that negative 4 stays exactly where it is. Okay? Then I have a to the 3 minus negative 1. So be careful there, because I'm moving that a to the top. Okay? Then I have b to the 2 minus 5. So I have negative 4, a to the 4th power, because that becomes plus a positive. What's 2 minus 5? Negative 3. So what's the only thing I'm moving to the denominator?
The B.
The b. Okay? Okay. Now this next one, I actually think we're going to do it the hard way first. Can I go to the next screen? Okay. In this situation, simplifying what's inside the parentheses does make it easier. Okay? But I do want to show you that I can do it either way. So what I'm going to do first is I am going to give that negative 1 to everything, including the numbers. Okay? I am giving that negative 1 to the 15 and the 3. And that's weird for students. A 15 and a 5. I'm sorry. Thank you. 15 and a 5. Okay? So I'm going to have 15 to the negative 1. Then I am going to have x to the negative 1 times negative 1. Then I'm going to have y to the 2 times negative 1. Okay? Then in the denominator, I'm going to have 5 to the negative 1st power, x to the negative 1st power, and y to the negative 4 times negative 1 power. Okay? So 15 to the negative 1, x to the first power, because negative 1 times negative 1 is positive 1. Then I'm going to have y to the negative 2 power, 5 to the negative 1, x to the negative 1, and y to the 4th. Okay, let's look at the numerator first. Numerator first. What do I need to move to the denominator from the numerator? 15. Okay, so then I'm going to have 15 to the first power. What else from the numerator needs to go to the denominator? Y. Okay, so then I'm going to have y squared. What stays in the numerator? Good. Okay, now in the denominator, what gets moved to the numerator?
Y to the second. No, wait.
Okay, what about, look at our number. What's our number? Good. What else? So the x to the negative 1 goes to the numerator. So what do I have in the numerator? Okay, so because I have x to the negative 1 in the denominator, x to the first goes to the numerator. Okay, what about the y to the 4th? Does it stay or go? Stays. Okay, so now I have 5x squared over 15y to the 6th. And I'm almost done, but what else can I do?
Divide the 3s. Wait, divide the 5.
The 5s. 5 goes into 5 once, 5 goes into 15 3 times. So my final answer to this is x squared over 3y to the 6th. Okay? I think that is the more complex way to do this particular problem. So I'm going to show you how to do it when we simplify first. So I have 15 x to the negative 1, y squared, over 5x y to the negative 4. Okay? What is 15? Oh, and all of that is raised to the negative 1. But what we're going to deal with is we're going to deal with this first. We're going to deal with that first. What is 15 divided by 5? 3. Okay? Then I have x to the negative 1 minus 1. Okay? Because this is to the power of 1, and I'm subtracting. Okay? Then I have y squared minus negative 4. Okay? And that's this right here. 2 minus negative 4. So once I've done that, I'm left with 3x to the negative 2 times y to the 6th. You could move that x to the denominator. I'm not going to because I'm just going to end up moving it back. So now it makes it easier to give everything that negative 1. So I'm going to have 3 to the negative 1, x to the negative 2 times negative 1, y to the 6 times negative 1. Now, what gets moved to the denominator? The 3 and the y. And x squared stays in the top. Okay? You can do this either way. I think option 2 on this particular problem is easier. I think option 2 on this particular problem is easier. Can I go to the next screen? Okay. We are leaving exponents. We are leaving exponents and we're going into perfect squares. We're going into perfect squares. So I want you to take a second and I want you to write down that table. Write down that table for me. Okay? 1 squared is 1. Okay? 5 squared is 25. 8 squared is 64. So if I ask you to take the square root of one of those numbers in red, I will get the number in blue. So the square root of 81 is 9. Okay? So squaring a number and taking the square root of a number are inverses of each other. Okay? So if I multiply 2 numbers together, what's the inverse of multiplication? Division. If I add 2 numbers together, what's the inverse of addition? Subtraction. If I square a number, the inverse of that is square root. And that's what we're going to focus on. Most of the things that you deal with are going to be to about 10 squared. Okay, you might go up to 12 squared, but I went ahead and listed to 15 squared. Okay? I do expect you to be okay with up to 12 squared. Okay? Has everybody got this table? A couple people? Nope. Are we good? Okay. So, if I have the square root of 9, what is the square root of 9? 3. Okay? The square root of 144? 12. Okay? So if we are asked to take the square root of a perfect square, and that's what that list was, is our perfect squares, we're going to get a whole number or an integer, and we're going to be fine. The issue is when I have numbers inside a square root that's not perfect. So this 8 right here is not a perfect square. I still have to be able to simplify it. So what you do is you break the number down. Break number down into a perfect square factor. Okay? So you are looking for perfect square factors. And the first one, I've got the square root of 8. So I am going to break down 8 until 4 times 2. Does 4 times 2 still equal 8? Yes. Can I take the square root of that 4? What is the square root of 4? 2. So as soon as I take the square root of this, it goes to the outside. So the square root of 4 is 2. So I put the 2 on the outside, and I keep the other 2 inside. And that's read 2 on the square root of 2. That's how that's read. Okay? Now I want us to look at 45. I can break 45 down to 15 times 3. Is 15 times 3 45? Yes, it is. Is 15 or 3 a perfect square? Are either one of them a perfect square? No, they're not. They're not a perfect square. So it doesn't help me to break it down if I haven't broken it down to a perfect square. Okay? So, what is a better way for me to break 45 down? Yes, 9 and 5. Okay? Because 9 is perfect. What's the square root of 9? 3. So I put that on the outside. What am I left with on the inside? 5. And I read that 3 on the square root of 5. 3 on the square root of 5. Okay? Can I go to the next screen? Okay. The square root of 50. Again, we may think, 10 times 5. The square root of 50 is 10 times 5. Is 10 perfect? No. Is 5 perfect? No. So that doesn't work. What do? 25 and 2. Okay? 25 and 2. The square root of 25 is 5. So I put that on the outside. What stays inside? 2. 5 on the square root of 2. Now, if I didn't know that 50 was 25 times 2, or I didn't know that 45 was 9 times 5, I could do the prime factorization. And I'm going to do the prime factorization on both of those. Okay? So I'm going to do the prime factorization of 50 over here. So I have 50. Okay, it breaks down to 10 times 5. And then it breaks down to 2 times 5. That's the prime factorization. So I'm going to go back, and inside my square root, I'm going to write the prime factorization of 50. I have 2 times 5 times 5. Okay. If there are 2 of the same number, inside the radical, that simplifies to 1 on the outside. Okay? So if I've got 2 5s on the inside, I'm going to put 1 on the outside. And those disappear. Okay, so what do I have left on the inside? Just the 2. Okay? Now I want us to do that with 45 as well. So I'm going to go back one screen. Okay? So if I don't know that 9 times 5 is 45, I can do the prime factorization of 45. Okay, I can do 15 times 3, and then I can do 5 times 3. Okay, so inside my radical, I have 3 times 3 times 5. If I have 2 on the inside, how many do I have on the outside? Okay, and then they disappear. Once I take 1 out, both inside disappear. So I'm left with 3 on the square root of 5. That's just another way to do it. Most students prefer trying to find the perfect square factor. Most students prefer that. Okay? Now, I've got one more that I want us to do. Now, what happens here a lot with the square root of 80 is students say 4 times 20. Okay? They almost always say 4 times 20. Yes?
When it's actually 4 times 4 times 5, right?
Yes, it is. Okay? So students will say 4 times 20. And they'll take a 2 out. Okay? So what's the square root of 4? 2. So then I would have 3 times 2 on the square root of 20. But 20 also has a 4 in it. So then I've got 4 times 5. What's the square root of 4?
2.
2. So then I have 6 times 2. So the better way to do this one is 3 on the square root of 16 times 5. You've got to find the largest perfect square, not just a perfect square. You've got to find the largest perfect square. Okay? So the largest perfect square in this one is 16. So I have 3 times 4 on the square root of 5. Now, if you don't know how to do that, if you're like, that's tough, Alicia, I don't get all that. We can do 80. 80 is 8 times 10. 8 is 2 times 4. 4 is 2 times 2. 10 is 2 times 5. Now, when I write this, so I've still got a 3 on the outside. Okay, I've got a 3. I'm going to rewrite this as 2 times 2 times 2 times 2 times 5.
Well,
Okay?
I just stopped when I got to 2 numbers.
That's fine. That's fine. Okay, now my 3 stays on the outside. If I have 2 on the inside, how many do I pull out? 1. So these disappear, and I have 1 on the outside. Okay? What about my next set of 2's? Good. And then I have a 5 left. 3 times 2 is 6 times 2 is 12. So you can use prime factorization to solve these, or your best method is to find the largest perfect square. That's your best method, is the largest perfect square. Okay? Okay.